Hello friends, welcome back to my channel Learning Physics with Bhavya ma'am. Today we are going to discuss numericals based on electrostatic potential and capacitance. So this is one of the important numerical asked for 5 marks. There are 4 charges of 2 nanocoulomb, 4 nanocoulomb, minus 3 nanocoulomb and 10 nanocoulomb are kept at the 4 corners of square of side 2 root 2 meter. So we need to calculate the amount of work done in moving a charge of 30 microcoulomb from infinity to the center of the square. This is a question. I hope it is clear. There are 4 charges. Okay, you have to keep like this in cyclic order. A, B, C, D is a square. So the charges are 2 nanocoulomb which is kept at place A. Okay, so charge Q2 is kept at the place B. So at the vertex C, charge 3, that is Q3 minus 3 nanocoulomb is placed and 10 nanocoulomb is placed at D. And if you join the diagonals of square, then you will get point of intersection. This is a center of the square. And we have to bring one charge that is 30 microcoulomb from infinity to the point O. So infinity is a point where the total potential is 0. So what is infinity? It is a point where total potential is 0. So from that point, so from lower potential, we are moving the charge from lower potential to higher potential. So then extra effort is required. So work is required to bring a charge from lower potential to higher potential. So how to find out the work done? Work done in moving a charge q from any point. So here infinity to the center of square can be calculated using this formula, that is W is q into VO minus V infinity. Here first you have to write potential at higher. See, this is a potential at next point, final point. Okay, this is a potential at initial point. So VO means we are finally keeping the object charge at O. This is initially the uh, charge is at infinity. Okay, this is at higher potential, this is at lower potential. So how to find out W? W is charge into final potential minus initial potential. Okay, Q into VO minus V infinity. But we know that V infinity is 0. That means we need to find out total potential at center of the square. VO means center of the square. So potential, total potential at the center of square is algebraic sum of potential due to charges at individual charges. Okay, so charges placed at A, B, C, D. Okay, all these charges produces total potential at O. So how to calculate total potential at O? It is an algebraic sum of potential due to individual charges. So how to calculate that? We know the expression V potential is Q into source divided by the distance. This is a formula, right? Using this formula, we can calculate total potential. So K is nothing but 1 over 4 pi epsilon naught and Q1 divided by the distance. See, charge is placed at A and we need to find out total potential at O. So what is the distance? AO. Here we need to write AO. 1 over 4 pi epsilon naught is common for all the expression. Let us take it outside. And second charge Q2 by the distance BO. Third charge Q3 by the distance CO. Fourth charge QO, the distance is DO. It is very simple to write. Okay, VOA. See here how to write this. Potential at O due to charge at A. Potential at O due to charge at B. So we are going to calculate potential at O due to charge at C. Potential at O due to charge at D. And same thing you are going to repeat again. See, charges are Q1 and the distance is same thing. VOA or AO, whatever you can write. So charge at B is Q2 divided by BO. Q3 by CO, Q4 by DO. And we know that how to calculate this AO, BO, CO, DO. For that, first you have to calculate diagonal. First thing is, after writing this square, you have to calculate diagonal. That is the first thing. And you will get 1 mark for calculating diagonal. So what is the formula? Using Pythagoras, we can calculate Pythagoras theorem, we can calculate diagonal. So here there are two diagonals, right? One is AC, another one is BD, right? So AC and BD both are equal. AC and BD is equal to, so this is a hypotenuse of right angle triangle, right? So AC square is AB square plus BC square, right? Therefore, AC is equal to square root of AB square plus BC square. AB square plus BC square. Therefore, how to calculate? AB is given as 2 root 2. So, square it. 2 root 2, square it. So, if I square this 2 square is 4. Root 2 square is, say, root and square cancel. Therefore, it will be 2. Similarly here, right? So, therefore, 4 into 2 is 8. 4 into 2 is 8. 8 plus 8 is 16. Square root of 16 is 4 meter. Therefore, diagonal is 4 meter. But A to O, B O, C to O, D to O, all these are half of the diagonal. So that's why diagonal by 2 is 2 meter. We came to know that all these four are equal 2 meter. So that's why here if I substitute, all these are equal 2 meter only, right? So I'll write 1 by 4 pi epsilon naught as 9 into 10 to the power 9. And charges, all these four charges are having same power, nano coulomb. Nano means 10 to the power minus 9. Take it outside. Remaining is charges. First charge is 2. The distance is A to O, 2. Second charge is 4. The distance is 2. Similarly, third charge is minus 3. That is, you have to write, okay? Minus you should mention. Minus 3 by 2. And 10 by 2. So, 2 by 2 is 1. 4 by 2 is 2. Minus 3 by 2 is minus 1.5. 10 by 2 is 5. Adding all this into 9 gives 58.5 volt. And substitute here to find out W. So, W is, how much you will get? W is equal to Q is 30 microcoulomb, VO is 58.5 minus V infinity is 0. V infinity means potential at infinite point. So potential at infinity is 0. So substituting, we'll come to know that it is 1755 into 10 to the power minus 6 joule. 10 to the power minus 6 is called as micro. So therefore 1755 microjoule is a work required to move a charge 30 microcoulomb from infinity to the center of the square. Is this clear? Is it clear, student? Hope you followed properly. So first thing is you have to find the diagonal and calculate the distance AO, BO, CO, DO, which is diagonal by 2, half of the diagonal, and substitute that here. Okay, so you just use this formula to find out W. Okay, if you like my videos, please like, share and subscribe my channel. Thanks for watching.